Hello everyone. Welcome to another class. Today we will learn about the superposition principle. Sometimes, circuit can be too complex for analysis. To handle it, some theorem have been developed. One of these is the superposition principle. The principle states that the voltage across or current through an element in a circuit is the sum of the voltages across or the current through that element due to each independent source acting alone. The principle rests on the linearity property, meaning that contributing currents and voltages will add up to give the actual current or voltage. The steps for the principle are as followed. Step 1. Turn off all independent sources except one. Something to know: when turning off an independent voltage source, it is short-circuited. The voltage will turn to 0 volts. To turn off an independent current source, the source turns to an open circuit. The current will be 0 amps. Step 2. Find the output voltage across or the current through any element on the circuit. Step 3. Turn off the independent source and on the next one. Step 4. Find the output voltage or current of the same element. Step 5. Repeat the process with all the independent sources. Step 6. Add all the output voltages or currents of that element to find the actual output. Now let's explain the principle with an example. In this example, use superposition to find VO. Start by turning off an independent source. Let's off the 4 amp source by opening it. Find VO. Instead of VO, we will call it VO1, because it will be one of the contributions in finding VO. With the current source removed, the circuit becomes a series circuit and you can find VO1 with voltage division or any other type of circuit analysis method you want to use. Now we will turn back on the 4 amp current source and off the next independent source. We will off the 10 volt voltage source by shorting it. We will now find VO, which we will call VO2. Another contribution to VO. When the voltage source goes off, the circuit looks like this. Using nodal analysis, we can find the node voltage and use voltage division to find VO2. Now we go back to the original circuit and gather up the voltages that contribute to VO. Add them up to find the VO output. VO in this case will be 6 volts. Here we have another example. Use superposition to find Vx. This circuit has 2 independent sources, so there will be 2 Vx voltages that will add up to the actual Vx output voltage. Start by offing a source. Let's say the 20 volt source. It is shorted. Vx will become Vx1. After the voltage source is off, the circuit looks like this. We can find Vx1 using nodal analysis. Vx1 equal 20 volts. Now we have found it, we will turn the voltage source back on and turn off the next independent source, which will be the 4 amp current source. The 4 amp source will be shorted. Now we can find the node voltage Vx2. The node voltage equals 5 volts. With Vx1 and Vx2, we can find Vx by adding them together. Vx equals 25 volts. With that comes an end to the lesson. Thank you for listening.